Yeah, so yeah, I was just trying to say at the bottom of that email that, I'm sending this Wednesday at 1:45, so please let me know if it takes a while for it to reach you. Somebody was complaining that my emails were not getting there in time. So instead of sending that as an announcement or a course announcement, I sent it as an email. So hopefully that sped up the delivery. Okay, so let's see. I think that's all we got here. So let's go ahead and share screen. I've had quite a horrible morning. So, I had a flat tire, so I spent my morning dealing with the flat instead of getting the last second stuff done for you guys. But that doesn't mean we'll be okay. So I'll just bear with me for 1 second. I need a background here. I need some.
Yeah, I got a question.
Yeah.
So like the math that we're doing with this integral stuff, like it's been a while since I took like calculus. So I don't. What calculus is this from? Like this calculus 2 or?
So far, this is whichever one is the one where you do integrals.
Oh.
That's probably calculus 2.
Yeah.
But I don't know exactly. Each university does their calculus series in different ways. When I went to university, I was on the quarter system. So, calculus 1 was derivatives, calculus 2 was integrals. And I don't remember what calculus 3 was. I think, calculus 3 was calculus with multiple variables, I think. So, I don't know what it is at UNO. I have not taken it at UNO. So, but it's integrals. Okay. So, anyway, so we were looking for, last time I drew this. Yeah, this is Y. This is X. Okay, so, and I said, okay, well, we've got a triangle that looks like this. I'm just, it's not exact, but it's something along these lines, right? And I said, okay, so this is 2 and this is 4. Okay. And what we're looking for is we said, where is the centroid? Okay. And what we proved yesterday, and I didn't use variables. A lot of times when people are introducing this concept, they will not use 4 and 2. They'll use like B and H, B for base, H for height. But what we solved for X bar is we said that X bar ended up being 2/3 in this case of the base, which was 4. Oh, not H, 4. Okay, my dog is going to drive me nuts, I can tell. Okay, so that was 2.6667 in this case. Okay, now what I want you to note is this has units, right? So whatever this is, if this were feet, then this would be feet. Okay, and maybe I'll just leave this in feet so that we will have a unit so that I don't. Okay, so what I'll show you in a second. Rocky, please stop growling. That's really unpleasant. Okay, sorry. All right, so we're going to do Y bar here. And Y bar, I'll explain this to you. I'll show this to you in a second. But if you go to the statics equation sheet, this is a triangle. And we kind of already know the answer here, but I'm trying to teach you this integral method because the integral method is one of the 2 methods you're going to need to know. If something is like a pretty regular shape, a rectangle, a triangle, a circle, whatever. If it's one of those, you can just look these up on a chart. But in this case, so like this is a Y bar is this is a triangle, so it's going to be 2/3 of the way through this thing, so or 1/3 depending on which side you go. So remember, the centroid is kind of like the center of the area. So this is the centroid of the area, or the center of the area. So I already know the answer in this case. Okay, in the X direction, it's 2/3 the way of 2 point. In the X direction, it's 2.6667 feet. And in the Y direction, it's only going to be 1/3 the way up. So it's going to be 2/3. It's going to be 2/3. So 0.66667. Okay. I already know that's going to be the answer. Okay. And, you know, we can look this up on a chart and I'll show you the chart in a second. But basically it looks like, you know, and you have to think about it as like, okay, it's going to be closest to, you know, the side that has the most area. Okay. I forgot what our guess was for this, but I think the guess out there was this was going to be 1 or probably a little less than 1. And we're just going to go ahead and prove that real quick. And I'm proving this because this is the, you know, you're going to need to know how to do this method. Okay. So, I want to recall. Okay. So I'm going to erase this real quick. Okay. And I'll do this a couple times today with different functions. And hopefully I can make this clear to you. Okay. And I guess I'm going to erase the answer too, because that's kind of in the way. All right. So what we're going to do, and I'm going to set this up 2 different ways, because there can be different ways that have different values, or there's a value to doing it both ways. Okay. So the formula here, if you have to use the integral formula, which for a triangle you wouldn't have to, but again, I'm just doing this for simplicity. Okay. Is y tilde dA. Okay. So what we're going to do here is we're going to focus on, okay, we need to figure out what this dA is. So keep in mind that this is the, so many dogs. Okay, this is if you integrate all the dAs, you get the area of the shape. Okay, so in this case, it's a triangle. We could just say 1/2 base times height, and we'll get that integral dA on the bottom. On the top, okay, this is the weighted average of, or the weighted total, I guess. So the whole thing really is a weighted average. This is, hey, get out of here, get, no dogs. Go somewhere else and play. All right, so this little y tilde, that is the centroid of the dA, okay, or the y centroid of the dA, okay. So what we're going to do here is, and there's 2 ways you can do this, and this can be problematic, or it's actually a benefit. And I'm going to do this 2 ways. I'm going to do this with triangles or rectangles that go this way. Okay, because remember, when we integrate, we're adding up all of these little, you know, there's a bunch of these. Okay, and we're going to add them up from the, you know, from x equals 0 to x equals 4. Okay. The other possibility is I could integrate going the other way. Okay, and so we'll do that as well, where my rectangles are actually horizontal. Okay, so I'm going to do this one first. And really, what's going to happen for every problem is that you're going to have to figure out which way is best. Okay, and I know that stinks. Like I can't tell you which way is better. Okay, so here's my y bar. Okay, and I'm going to start with the bottom because it's easier. Integral, okay, dA. So basically what I'm saying is, what is the area of this box? Okay, now I want to remind you this again. Okay, I'm going to say this every time. This location right here is x comma y. Okay, now this confuses a lot of students. It doesn't seem like it should, but it will. Okay, this distance right here, that distance is x. And this distance right here, okay, that distance is y. All right, so now what we're going to do is we're going to do my dA. Okay, now the only other coordinate we need for this thing is right here. Okay, that little thing right there, that's dx. Okay. All right, so now we're just going to try to figure out what is the area of this little differential area. Okay, well, it's a rectangle, so it's length times height. Okay, so the length of this thing is y. Okay, and the height of it is y, and the width of it is dx. Okay, so that's the dA. All right, and then noting that we're going to add those up from x equals 0 to x equals 4. Okay, so we'll go from 0 to 4. Okay, so on top, we're going to have the same thing, 0 to 4. And so I've got the same dA right here. So that's going to be y dx. And then I just need to put in the y centroid of dA. Okay, so where do you think the centroid of a rectangle is? Well, if I told you I had a rectangle and this height was, I don't know, 7, and this was, I don't know, 10, well, you would be right to say, well, the centroid is going to be at 5, 3.5. Okay, so basically it's half the height. Okay, so in this case, well, what's the half of a height of a triangle that has a height of y? Well, it's going to be y over 2. Okay, questions before I move on? Okay.
Oh wait, but it's a triangle though. So why you put y over 2?
Because I'm talking about this rectangle right here.
Oh, okay. So it's y over 2, y dx. Okay.
All right. So then the last bit to solve this, okay, and granted, you wouldn't do this for a triangle. You would do this for a, some sort of irregular shape. You wouldn't do this for a triangle, but a triangle is easy. So we start with a triangle. Is now, we've got dx's. Okay, so now this is just pure calculus. Okay, setting up the integral is also technically pure calculus, but you haven't done this before and it's been a while. So, so in this case, we've got dx's, but we've got y's. Okay, but we've got y's over here. So we need our y's to match our whatever is behind our d, right? Or we need our variable to match whatever's behind our d. So we've got dx. So we need those y's to be turned into x's. Okay, so all the points along here, this is y equals mx plus b in this case. So the equation for this line is y equals 1/2 x. Okay, so because the slope is m, so that's 2 over 4, and then b is 0. So what we would do to solve this is I would say, okay, well, y bar equals from 4 to 0 of, well, let's see, I got that 1/2. I'm going to pull it out. I'm left with a y squared. And in place of y squared, I'm going to have 1/2 x squared dx over integral from 4 to 0 of, oh wait, is that right? Yeah. 1/2 of x dx. Okay. That can be solved. Okay, I think like that's a tractable solution. If ever I give you an exam and I say, just set up the integral, this is what I want to see. Ideally, you would simplify it a little bit more than this, but I want to see that you can get it into a form that you could solve. I don't want you to spend a lot of time. If I ask just for you to set it up, it's because I don't want you to spend time integrating. I'm just trying to save you time on the exam because I have other things that I want to ask you. Okay, here's another possibility. Okay, and I think that probably you will see this possibility done on some other things. Okay, so now this way, it turns out, I think in this case, it's going to be harder. But sometimes you just don't know until you begin it. Okay. So let's see. So I want to remember that this is x and this is y. Okay, so those distances. Okay, and if you need to, I recommend drawing that. Okay, to help you to figure out what's going on. Okay, so in this case, this is going to be our rectangle is here. And hopefully you can already see that this is maybe a little bit harder. Okay, and hopefully you can see why. Okay, not why, but anyway. So here, let me do this in blue. This little thing right here, that's a dy. Okay, I highly recommend you draw these little rectangles out. Like a lot of people don't want to do that. I have no idea why. It totally helps. Okay, so again, we're going to do the bottom first, the dA. Okay, the problem with this is this distance right here is not so clear. Okay, and the last one, like for the height of the triangle, I was just able to go, oh, okay, well, the height is, y. Well, in this case, that is not x, right? You can see where x is. This is actually, well, let's see, right here it's 4. So this is actually 4 minus x. Okay, because basically I'm going to take this whole distance and I'm going to subtract off that x. Okay, so for my dA, it's just the area of that differential of that rectangle. So we're going to say the integral. Okay, now I'm just going to do the area of that rectangle, 4 minus x dy. Okay, that's just the area of a rectangle. Okay, now these are dy's, so they're stacking up from the bottom to top. So they're going, here's the top, here's the bottom. So what are my y values of those points? 0 and 2. Okay, question on that before I go on. Okay, so then we're going to do the same thing up here. We're going to go from 2 to 0. I'm going to have the same dA, 4 minus x. Here's my dy. And then I need the y tilde. Okay, so I need to know, where is the y centroid of this box? Okay, so we know that the box centroid is about right here. Okay, and if we look at that, oh, look, it's just y. Okay, so this is just y. Okay, cool. Now the last little bit. Oh, wait, any questions? Okay, so then the last little.
Wait. So like you multiplying that 4 minus x times y, because how do you know if that's like would like how you know you don't how would you know if you needed to multiply by something other than y?
Well, y is the y centroid of the dA, of this differential area. So in this case, it's just the distance from here up to that centroid, which just so happens to be the exact same as y.
Oh.
Usually it's going to be y, or it's going to be y over 2, or usually it's going to be something like that.
Oh, so wait, why was it y over 2 last time?
Because the box went like this. So the centroid was located right here. The y centroid was right there. So this had units of x comma y. So this was x going this way. And this was y going this way. And so how far away is this in the y direction? Well, it's half of that.
Oh, so that's it depends on the location you choose.
In this case, it kind of, well, no, because it would have been the same if it was x comma y. If it was right here, it would still be half of y. But it has to do with the direction of the box. Because where is the y centroid? Well, the y centroid is right in the middle of this box. Right? So the middle of this box, if the box is going this way, is only halfway up. The middle of the box, if the box is going this way, is all the way up. Does that make sense?
Yeah, kind of, sort of, yeah.
Okay, so let me, so then the last bit to solving this is right here. We got a dy, but we've got these x's. The x's are annoying. So what we would do is we go back up to this equation right here. And I want to solve in for x to get y. So I would rearrange this to get x equals 2y. Okay, same equation, just rearranged. And I would just plug that in over here. So I'm going to do y bar equals the integral from 2 to 0 of y 4 minus 2y dy over the integral from 2 to 0 of 4 minus 2y dy. Okay, so these are both set up. Now the question is, which one is easier? That's the one that you would solve.
How you got 4 minus 2y? How you got that? How you go from?
So I plugged in x equals 2y right here. I plugged in.
How you get x equals 2y?
Okay, this is the equation of the line. I multiplied both sides by 2.
Oh, okay.
All right, so yes, I'm plugging in 2y in here. And now we just need to figure out which one of these is easier to solve. Okay, and so really, if you're doing this and you're like, I always like to use vertical boxes, you can always use vertical boxes, and you don't really care, you can always do a vertical box. Or you could always do a horizontal box, but sometimes that's going to be like almost intractable. In this case, neither of these integrals is really all that difficult. So I could go like, I could do this one, I could do either one. Okay, so in this case, y bar equals, so it's at 1/2 squared. So we got 1/8 over 1/2. And this is going to be x squared, integral from 4 to 0 dx. And this will be integral from 4 to 0 of x dx. Okay, over here, I'm going to say that y bar equals from 2 to 0, 4y minus 2y squared dy over the integral from 2 to 0 of 4 minus 2y dy. Okay. For most of us, I think the one on the left is going to be easier, but you can do either one. I'm just going to walk through these. So this will be x cubed divided by 3. So this will be 1 over 24. And we evaluate that from 4 to 0. And this one's going to be x squared, 1 over 4, from 4 to 0. Okay, and then y bar equals, okay, maybe I'll do the bottom first. Okay, from 2 to 0, this is going to be 4y minus y squared. Yeah, y squared, just y squared. That's interesting. Oh no, that's right. Okay. And then and then up here, we're gonna go from 2 to 0. And we're gonna go y squared 2y squared minus 2/3 y cubed, like that. Okay. Now notice the bottoms. The bottom, that's just the area of the triangle. So in this case, what's the area of this triangle? Well, it's 4 times 2 divided by 2, so that's going to be 4. So in both cases, we should end up with 4 as on the bottom. So if I plug 4, if I do the bottom of this one, I do indeed get 16 divided by 4, which is 4. Okay, and if I do the bottom over here, well, I get 8 minus 4, which is 4. Okay, and then we'll do the tops. So we'll get, what's that, 4 cubed. It's 4 times 4, 16 times 4 is 64. 64 divided by 24. Okay, 64 over 24. I'm just going to leave it like that for now because, calculators and whatnot. And then over here, what I get, 8 minus 2/3 of 8. So I'm going to get 1/3 of 8. So it's 8/3. All right, so then this y bar becomes 64 divided by 24 times 4. Okay, 0.666, basically it's 2/3. Okay, and that has units of feet. And then this y bar equals 8/3 divided by 4, which is 2/3, 0.66667 feet. Okay, 2/3. Okay, so that's how we do it. Questions?
All right, so I know one of these you're doing from the x-axis, one of them you're doing from the y-axis. Can you explain the difference, like just so I know I can understand how to set it up?
Yeah, same. Are you just like I understand like the second side. I don't really understand the first side, like the 1/2 4 to 0 integral.
Okay. So you don't understand how I got these numbers.
Yeah, because I get the second side. That's like the second side is kind of obvious. Like it's just 2 to 0 because that's how the x is. The y is, I mean.
Okay, let me work another one and
Is
we'll do
the x side, I mean? So left side's the x side, right side's the y side, right?
X side, Y side. I mean, you mean which direction I made the boxes?
Like
For this one, for this side, I made the boxes like this. And for this side, I made the boxes this way.
Oh, okay.
Okay, it's just different ways to approach the problem. You could have done it either way.
Okay, I thought you were solving it like. Okay, no, my bad.
Let me,
So how you get the y over 2? How you get the y over 2 versus y and versus 4 minus 4? I mean 4 minus x.
okay. All right, so in this case, okay, when we've got a vertical triangle like this, okay. Okay, what is this? What is this? What is that? What are the coordinates of that dot?
X, y.
X comma y, right? Okay. Okay, the centroid is right here. What's the coordinates of the centroid?
I don't know.
Okay. How did you know that this was X comma y?
Because that's the point on the line, the line 2y.
Right. Okay. So compare this X coordinate to that X coordinate. Same, different.
Wait, compare what x coordinate to what x coordinate? Or,
This X coordinate at the centroid.
oh, so it's gonna be y half of.
No, just the X coordinate.
Same X, right?
Yeah, same X. Okay, what about the Y coordinate?
It's just okay. I don't know.
You don't know. What's the Y coordinate right here?
Why?
Y. So now we're at the centroid of this rectangle.
Would it be 1/2 y?
Y over 2.
Ah, so the y coordinate of central y over 2.
Yeah, of a rectangle. Sure. If you have a rectangle, like this rectangle over here. Okay, it's 7 on this side, 10 on this side. So the Y coordinate is 1/2. Okay, it's just right in the middle.
Makes perfect sense to me.
Okay. So so that's where the Y over 2 comes from. Okay. Now on this case, however, right, that centroid is located at, well, it clearly doesn't have the same X coordinate. And the Y coordinate, though, is the same as whatever we have right here. So the Y coordinate of the centroid is Y. The X coordinate, which we didn't do, would be a little bit harder, right? So basically, we have to take this original X right here, X, and then we'd have to add this little bit to get over there. Well, what's that little bit? Well, it's 4 minus X divided by 2. So this whole distance right here would be X plus 4 minus X divided by 2, which is kind of annoying. We'd have to that number would go right here, right? So we'd have to do algebra for that. We
4
didn't.
minus x divided by 2. That's x. Oh,
What's that?
so that's what x is.
That's what X of the centroid would be, yeah.
Wait, so it's minus x. Oh, you did plus x. It's x plus 4 minus x.
Over 2.
No, it'll be minus X, right? Wait, what?
Okay, so I'm going to X to get to right here. And then I need to go another half of this box.
Yeah.
A little ridiculous. So I'm adding half of 4 minus X, which is this distance right here. So I've got X plus 4 minus X, half of that. So that's what this is.
Makes sense to me.
Okay, so let me work another one, and then I'll work one where we don't know the answer. Okay, so let's hold on. Let me find one off of an old exam. 1 second. Moodle. You'll like it better when we have composite shapes, but let's work another one, and hopefully this will make it a little bit more clear. Statics. Okay, let's see here. Oh, old exams, where are you at? Old tests. This will be on the final. some kind of weird makeup final. I don't know why I had a makeup final. Woo! Ooh, that's nasty. Okay, here's a nasty one. You know, every now and then there's a hard one. I don't normally like to give ones this hard. All right, I'm gonna clear all. Well, I'm just gonna move it over here. This is much nicer. I don't need to clear everything. All right, determine. Oh, that's a moment of inertia. Okay, well, it's a moment of inertia. We'll just do it as a centroid. Okay, so that's good. It'll be a whole new problem. Okay, determine. Oh, let's get black. Determine location of centroid of the region bounded by y equals kx squared, the x-axis, x equals a and x equals 2a. All right, well, this is pretty annoying because this one, they don't really give you a lot of information. Okay, so, you know, we are lining up against the limitations of our math education. And the problem is they spend a lot of time teaching you guys how to, you know, integrate, but they don't tell you a whole heck of a lot about what integration is. And that's what we're doing right now. Okay, so it's not your fault if this is difficult. It's like, it's kind of a weak.
Is that x equals a or x minus a?
X equals a, yes, thank you. Okay, and what sucks here is they don't even tell you what a is. Okay, we can put numbers in there, but let's say this is a. All right, and so then, okay, y equals kx squared. If you know that's a parabola, so that's going to have a shape like this. Okay, let's see here. Let me go about here. So here, this is our shape right in here. Okay, so this is y equals kx squared. This is a. This is a. Okay, so this is x equals 2a. This is x equals a. Okay, so hopefully you guys are on board with this so far. Be nice to know what this point is right here and what this point is. Okay, just because it would be nice. Okay, so let's go ahead and get those points. Well, right here, x is a, and y is, well, I'm gonna have to plug a into this equation right here. Ka squared, Ka squared. Okay, and then this location, this is what, 2a, and well, we'd have to plug that into that equation, and we'd get what, 4Ka squared. We plug 2a into that equation. Okay, questions so far? Okay, now, as I always like to do, I like to do a guess. Anybody have a guess where the centroid is? Okay, if this is like, let's see, this is about x equals, let's say that's like 1.5a. Is the centroid closer to x equals a or closer to x equals 2a in the x direction?
Both.
2a. Anybody?
Wait, say the question again.
Okay, I'm asking, you know, we're going to guess where the centroid is. So in the x direction, is it closer to x equals a or x equals 2a?
Is the centroid affected by the y value?
It'll be closer to 2a, right?
It's going to be closer to 2a. Okay, so what it is remember, it's kind of like, where would I put my finger down here so that this thing would balance?
Probably like 1.75a.
Okay,
Yeah,
that's a pretty, yeah, like 1.75a might be a good guess. Okay, it's kind of hard to know, right? But certainly closer to 2a than it is to 1.5. I mean, than it is to just a. Okay, what about in the vertical? This is kind of hard because we're talking about like fractions of 4Ka squared, right? Because that's, you know, that's the max here. So it's probably going to be somewhere between KA squared and 4KA squared. Maybe, probably. I don't know. What do you think?
2KA squared.
2KA squared. Okay, so about halfway up. That's, 2KA squared, like, what are we even talking about here, right? It's a little weird. Okay, so I'm going to go ahead and erase this. We're going to go ahead and see what we end up with. Okay, now this one's annoying because we've got K's and A's, but K's and A's are just, those are just those are just numbers. We're just going to use them like it's a number. All right, so I'm going to solve this. And again, we're going to I'm going to set these up using boxes going in either direction. Okay. So remember, here's my box. And maybe before we start, we're going to locate the centroid of this box. Okay, so let's start with a vertical box. A vertical box. And I'm going to draw it a little bit wider so we can kind of look at it. Here's a vertical box. Okay, so we're going to do this vertical boxes. Vertical box. And maybe I'll solve for X bar and Y bar and with vertical boxes. Okay, so what is this point right here on the line? Anybody?
Where?
This point right here. What are the coordinates of this point at the top of the box?
XY.
X, Y. Okay, good. Okay, now what that means is that this distance right here, okay, to that point, I didn't draw it quite well, is X, and this point going this way to that point is Y. Okay, now because it's going to help me out, I'm just going to go ahead and I'm going to put the centroid in here. Okay, what are the coordinates of that centroid, of that rectangle?
XY over 2.
X comma Y over 2. Good. Okay, now we have everything that we need to solve this. Okay, that's probably a better way to approach this, is like that. Does everybody see that?
No.
Oh yeah, that's I think that's very good.
Okay, so then what we'll do is, okay, so then now we've got the vertical box, so we're gonna
How
do,
did you get Y over 2?
okay, because, so the location of that point is halfway up here. Okay,
Okay, I'm sorry. I see it. Yeah.
does that make sense?
Yes, it does.
Okay, so then we're gonna say, okay, so here we go. Let's start with X tilde. X or X bar, okay, equals the integral of, X tilde. Okay, so that's this. So this would be X tilde, Y tilde. So that's the centroid. That's the location of the centroid of our little box. Okay, dA. Okay, divided by the integral of dA. Okay, so dA is just the area of that box. Oh yeah, the one last thing we need for that box is this distance right here. That's dx. Okay, so X bar equals, let's see here. Well, at the top, we need the X tilde. So that's just X. Okay, integral. And now we need that dA. I need the dA on top and I need the dA on bottom. Well, I know that the dA is just, it's just the length and the width of that box. So it's going to be y dx.
I'm sorry, Wayne, on the first example, my internet was cutting out. How does X tilde become X? I know you've already explained this.
Oh, okay. So we're looking for the coordinate. We're looking for the color here. This dot right here.
Uh-huh.
Okay. So this is X from here to here. All right. Well, we're in the exact same X position.
Yeah.
We just have a different Y. So X tilde is the location of the centroid of that rectangle.
Okay.
Okay. So now let's see. So to solve this thing, the last little bit, we just need to get these, we've got dx's, so I need to get rid of those y's. So we'll go ahead and do that. And we'll do that by saying, oh, okay, well, let's go. Oh, no, I want black here. Okay, so we'll go X bar equals, in place of those y's, I'm going to use this equation right here, y equals kx squared. Okay, so I'm gonna get x times kx squared dx over kx squared dx, and I need to put my intervals in here. Oh, and I forgot to put in my limits of integration, which are where we're going to go from x equals a, x equals 2a. Okay, so it'll be a to 2a, a to 2a.
So the vertical box method integrates with respect to x.
Yep.
Wait, so the y dx, what is that? What is the y dx?
The y dx is the area of the dA. It is the differential area.
Oh, well, so why is not y over 2 times x?
Okay, because it's the area of this rectangle right here. Okay, notice the height of the rectangle is y. The width of the rectangle is dx.
Oh,
Okay, so all right, so then at this point, solving this is, I don't want to say it's trivial, but at this point, like if I asked you to set it up, you could stop here. If I just said set up the integral and you don't have to solve it, okay, that would be because I want to save time for the exam. Otherwise, and I'm just going to do this really quickly, this is a fairly easy integral. Okay, so this is kx cubed dx. Usually when I give you these, the idea is to give you something that is easy. The integral is easy. I'm not trying to test your ability to integrate. But in this case, you should know how to do this pretty much off the top of your head. So this would be 1/4 kx to the 4th from 2a to a over, what is this? Kx cubed 1/3 from 2a to a. Okay, so x bar equals, kind of annoying, 2 times 2, or 2 to the 4th is what, 16? 16 over 4, so we're going to get 4k a to the 4th minus 1/4 k a to the 4th, right? And then on the bottom, we're going to get what, 8/3 k a cubed minus 1/3 k a cubed. Okay, so x bar equals whatever that is. Okay, 1/4, 4 minus 1/4 is 3.75. 3.75 k a to the 4th divided by on the bottom, it becomes 7/3 k a cubed. Okay, and x bar equals, well, the k's cancel, a lot of those a's cancel. I've got a certain number of a's, so 3.75 times 3 divided by 7. Okay, some ridiculous number, 1.6071. Okay. So that's how we would solve that. Okay, assuming that I did it correctly, there could be an error in there somewhere. Okay, math is difficult, right? Okay. So let's go ahead and we're gonna stick with the vertical boxes, and I'm gonna do the y bar. Okay, one interesting thing here to note is that x bar is not a function of k. Okay, so it doesn't matter if this k right here were 3 or 7 or 100. You know, the x bar is not going to change. So that's kind of interesting. Notice that this number 1.6071, okay, this guess was pretty good. Pretty good. Okay. Notice that we also assumed that it wasn't going to be a function of k, and we were right. We did assume that the vertical was going to be a function of k. Okay, so, and that seems highly likely. But let's go ahead and solve that one. So again, pay attention as we do this. Okay, so integral. Okay, integral. My dA, so that's the area of this rectangle.
wait, I think the screen blank.
You think the screen what?
No, I can see it.
Yeah, I could see it.
It might be on your end.
Okay. I would like to actually enlarge my screen, but it won't let me. Dang gummit. It's like, no, anyway, I'd like to be able to see mine, but it won't let me enlarge. Okay. Anyway, so, all right. So again, in this case, we can do the same. Well, let's just go ahead and write out the equation, dA over dA. Okay. Again, remember dA, that's just the area of that box. Well, the area of that box is integral of y dx. Okay. So the area of the box is, here's y, here's dx. Okay. Then on top, we've got the same dA, y dx. Okay. But we've got a different, we've got a different thing here. We've got y tilde. So y tilde is right here. That's y over 2. This is going to be y over 2 integral. Okay. So the one nice thing is if we ask you for the, if I ask you for the, hold on, let me enlarge this.
And that would be from 0 to x squared or 0 to kx squared.
Well, let's get there in a second. So, oh yeah, this is really hard. Whew. Okay, I forgot. This is messed up. I forgot how hard this is this one you would definitely not want to go this direction. Okay, because you just asked the most important question. Okay, the most important problem here. Actually, no, it's going to be fine here. Never mind. I'm going to show you why you wouldn't want to go horizontal in a second. But yeah, let's go ahead and solve this. So yeah, so let's go y bar equals. Now again, we've got a dx here. So we can't integrate with that with y's. So we want to change our y's into x's. So what we're going to do is we're going to take this equation right here. Okay, and I'm going to convert that. Okay, so it looks like that's going to be x equals y over k. Okay, square root. Right? Nobody's happy with that. Right? Nobody's happy with that. Right? So oh wait, wait, is that?
No, because you're integrating with respect to y now, right?
Oh yeah, you're right. You're right. So this is totally fine. Okay, we don't need to do this yet, but we will have to do this later. Okay, but yeah, you're right. We're good, right? So we can just plug this in. Okay, that's much happier.
So those dx's are actually dy's.
No, those are dx's.
Oh, yeah,
We're using the exact same box. As
Oh,
okay, we're using the exact same box. Okay. Yeah, so we're going to change those y's into x's by using this equation right here. So we're going to go, okay, we'll pull this 1/2 out the front because that's just annoying to me. And that's a y squared. But in place of y, I'm going to put kx squared. Okay, dx. And I'm going to integrate over here, integral of kx squared dx. Okay, now note, in this case, I don't need to do the bottom again. I've already done that, right? I did that right here. Right, so there's, it was the same bottom on both cases.
But
So-
why you square kx squared twice? Like, is kx squared?
It's because right here, I've got a y and I've got it multiplying by a y. So I've got a kx squared, which is one y, and then I've got a kx squared, which is the other y.
Oh, okay.
All right, so the bottom, I don't really need to do. I know that's going to be 7/3 ka cubed. Okay. And again, I'm doing this in the x direction, so I've got the same limits of integration. X equals a and x equals 2a. So I'm going from a to 2a. So I've got this 1/2. Okay, we're going to go ahead and let's see. I'm going to take that k squared and pull it out. And then I'm going to go ahead and integrate. What's that? X to the 4th. So that's going to become 1/5 x to the 5th from 2a to a. Okay. So let's see here. So y bar equals, again, we've just got this 7/3, which is kind of just along for the ride. And then I get this 1/2 and that 1/5. So that's 1/10. This k squared is still here. And then I've got x to the 5th. Okay, and then we got to plug in for that. So it's going to be what? 2 to the 5th is 32, I think. 32 a to the 5th minus a to the 5th. Okay, that's super annoying. A to the 5th. That's so ugly. Anyway, so we're gonna get y bar equals what's that? 3 over 70. That's an unusual number. 3 over 70. Right? One of those k's goes away. Two of those, oh, wait, so then this becomes 31. So we'll multiply 31 on the top. So this becomes 93. And this becomes what? A squared. Okay, there you go. Okay, and if we wanted to kind of make it look like the other one, we would get a fraction for that. So what's that?
Why is kx squared squared in the third step?
Kx, why is this squared? Because we've got a y squared. And so I'm basically changing y squared into kx squared squared because y equals kx.
Oh yeah, I forgot. Yeah, there's two y's. That does make sense. Okay.
Okay. So then this thing becomes 1.3286 Ka squared. Okay. So our guess over here of 2Ka, not too bad. Or 2Ka squared, not too bad.
Is there
Go
any
ahead.
way to, I guess, like double check yourself for doing this? Because I found myself as I was doing it, kind of get my numbers and stuff crossed up.
Well, what's your question?
Like, is there any like foolproof way to double check yourself or to make sure you're in the right direction when doing problems like this?
You can, the foolproof way to do it is do it with vertical boxes and then do it with horizontal boxes. So the foolproof way, unfortunately, is too time consuming to do during a test. So unfortunately, not really. This is a very hard one, by the way. Well, actually, if you did vertical boxes, it's totally reasonable. If you do horizontal boxes in this case, you're going to be in for a world of hurt. Okay, and I'm going to show you that in 1 second. And I'm not actually going to.
You'll know which way is better if you just set up the integral though, right?
Yep. Like when you get to this step right here.
You can be like, oh shit, that looks like a bad integral.
Right, like this integral is totally doable. It's just x to a power. Okay, in both cases. Okay, totally doable. And I'm going to show you what's going to happen in the y direction. That's going to make this really, really, really obnoxious. And that's going to show you why you shouldn't do the horizontal box. Usually for me, what I want, if I can get it, is I want a box that's going to go from my line to the axis, and that's what I want. Okay. If you go the other way, we've got two problems. Well, let me show you the other way, and I'll show you the problem with that because I'm not even gonna solve it because I think it's going to be too annoying. But if I ask you to set it up, you could always just set it up and then move on with your life. But it's going to be obnoxious. Okay, so let's do it. Okay, when using this program, I usually don't like to erase stuff because I can scroll around on this board, but I need this. Okay, so let's okay. I should have just started from a fresh picture. Okay, so this was 2a 4ka squared, I believe. All right. And this was going to be this is y equals kx squared. Here's my area. And this point right here is x comma y. And what else do we have going on? I think that's pretty, this point right here is a comma k a squared. Okay, so now we're sitting here and for whatever reason, your brain works a little different or you just like a challenge. And so you decide to do your box going this way. Okay, nothing wrong with that. In fact, sometimes a horizontal box is the way to go. However, it's going to create some problems because, and I'm going to go ahead and so let's go ahead and label this thing before we begin. So this height right here, that's dy. Okay, and now I want the height of that box, and that's kind of annoying because let's see, this right here, okay, that's the distance of x. This distance right here, that's the distance of y. Okay, which means that this distance right here, okay, that's 2a minus x. Okay, please pay attention and holler if something doesn't make sense. Okay, so our dA is, go ahead.
Wait, why is it minus x? What's the x? Or it's just minus x? Oh, I see. Never mind. I see. Never mind.
Okay, so then, so that's cool. So now we've got what we need for the dA, right? We've got 2a minus x times dy. That's going to be our dA. But then, all right, but then, okay, we need the location of the centroid, right? So this is of the centroid of that little box. So I think we're going to call that x tilde, y tilde. Okay. And the y tilde is easy or easy enough because it's the same as y, right? So it's just going to be y. But the x tilde is challenging, okay? Because basically I need to take this x and I need to add half of this. Okay, so x tilde equals x plus 2a minus x divided by 2. Okay, so with a little bit of algebra, that becomes x over 2 plus a, like that. Okay, so that's what goes right here for my x tilde, which unfortunately I didn't really leave myself a lot of space. X over 2 plus a, x over 2 plus a. One nice thing about working on a screen where you can move around. Okay, can y'all see how I got that x tilde?
And it's divided by 2 because you have 2 distances for those 2 small increments of distances.
Oh, sorry, can you speak up?
I'm trying to figure out why you have divided it by 2. Is it because of the distances?
Yeah, so I figured to get to that centroid, I have to go this distance, x, and then I have to go over half of this distance right here, of this 2a minus x.
Okay.
Okay. All right, so now we're going to go ahead and set this up, and I haven't shown you the biggest problem. So that's one problem, right? So just now I said, when I set these things up, I like to set it up so that, you know, I'm going from the line to the axis is my area, right? In this case, if I go to from the line to the axis, I'm not getting my area. I'm getting a whole bunch of empty space. Okay, so that's one problem. That's why we get this annoying, you know, that's why we get this, which of course no one really likes, right? It's annoying. It doesn't mean that it won't work. It's just, you know, obnoxious, okay? There's the other big problem, and we're going to get there in a second, and I'm going to see if you guys can spot it before we get there. Depends on, you know, again, this is your calculus ability coming through. Let's see, this is, okay. So what we're going to do, so this is the vertical, these are the horizontal boxes. Okay, so again, same formula. Okay, that's always the formula. And what we're going to do here, okay, is, okay, let's see. So X bar, let's just do the bottom first, dA, so that's the area of the rectangle. Well, the area of the rectangle is 2a minus x times dy, 2a minus x times dy. Okay, and on top, well, we've still got that same dA, so it's going to be 2a minus x dy. But now I need the x tilde, which is this annoying thing right here. which is x over 2 plus a. Okay, so you're already seeing that you're gonna have to FOIL in this case. And you know, we don't like to FOIL, but you could FOIL and it would be okay, right? It's not unreasonable to FOIL. It's
What
just,
would that mean?
what's that?
What's falling?
First outside, inside last.
Oh, like you multiply those two terms together?
Yeah. We'd have to multiply two binomials. No one, is that what they call it, binomials? Yeah, binomial is the word for these, right? Yeah, no one wants to have to do that, is all I'm getting at. You could do it though. Like it's not the end of the world. It's just time consuming. There's a bigger problem though. And the bigger problem is, what are my limits of integration? Anybody?
A to 2a. Oh, no,
A.
0 to a.
Okay, you're on the right track. But, okay. See how we've got these
No.
DYs? We've got DYs. So that means I'm going from, that means my books are stacked this way. Okay, so actually I need to go from a Y value here. What's my bottom Y value?
0.
Why?
Well, it's interesting. So we start here, and this, what I just drew for defining this square or this rectangle, it applies only until I get right here. After that, it no longer applies, right? Because then the rule for what defines that rectangle change. Right? Can y'all see that?
Yeah.
Okay, so that's problematic.
Wait, now, what you mean? What you talking about?
Well, so when I'm talking about this rectangle is defined as going from this point on this line to this point on this line. Okay, and that's true, right? Everything here that I just did is true until I get right here. Okay, this point is still
What
on that
changes?
line. Hold on. This point is still on that line. Point is still on that line, but from here down, the area is like this. Okay, so it no longer applies. It no longer works.
Or from A to 2a? Or
Yeah. Then it's going from x equals a to x equals 2a, which of course is lucky. Like that area is easy. But the problem is this particular integral will only get me the centroid of this top bit. It's not going to get me the centroid of the bottom bit. Okay, and I'll show you how to deal with that in a second. But right now, let's just get the centroid of this top bit, and I'm gonna give you the limits of integration for that top bit. So again, because this is dy, it's going to go from y equals ka squared to y equals 4ka squared. So so it's going to be ka squared 4ka squared. There's going to be ka squared 4ka squared. Okay, what's the last thing I would need to do before I were to solve this? If
You convert your x's to y's.
convert your x's to y's, right? So integral 4ka squared, and I'll write that out again, 4ka squared over ka squared. And then we're going to do, sorry, I'm going to murder my dog. And of course, my uncle's dog has wandered into my apartment and is barking too. All right, so I convert my k's to y's. I mean, my x's to y's, and I would use this equation right here. So again, super annoying. I would probably write this as x equals y over k to the 1/2, just because for doing derivatives and integrals, that can be easier. And again, you can see that this is going to be really annoying. 1/2 y over k to the 1/2 plus a 2a minus y over k to the 1/2 dy. In this case, I probably would have FOILed first before plugging in, because clearly you don't want to have to do a lot of algebra with y over k to the 1/2. On the bottom, we get 2a minus y over k to the 1/2 dy. Okay. Again, you could integrate that. The problem is it would only give us the centroid of the top bit. Okay.
Wait,
Go ahead.
Hello?
Okay, you're breaking up. When you come back in, holler.
So you
Can you
need
hear
to do, you need to do two integrals for the top and the bottom, and then like
Can you hear
average.
me? Hello?
Uh,
Yo. Hello,
yeah,
hello,
Jerry,
hello,
yeah,
hello.
Jerry, go ahead. Go ahead.
Oh, I don't understand. I don't understand the limits. I got disconnected.
Okay, so the limits, okay, if these are DYs, okay, these are the books. Okay, you got your stack of books. And you're from here to here. Okay, so what are those values? Well, this is y equals ka squared, and this is y equals 4ka squared.
Oh, so wait, why is it 4?
Why is it 4? Well, because x is 2a. So if I want to know what the y value is up here, I would say, well, what's the y value at this point? And so I'd say, well, at y equals kx squared, y equals k times 2a squared. So y equals 4ka squared.
Okay, I got it. Thank you.
Okay. Kyle, yes, you are correct. Okay. So what I want to do right now to show you how you would solve the rest of this. So you're right. I think Kyle, I think it was you that was speaking. I think your question was, so how do we get the rest of this answer? Right. And I think that hopefully you guys, if you set this up, you go, oh dear Lord, don't make me do this one. Right. Now you could do it. If this were a homework assignment, no big deal. It would take you an extra 5 minutes on an exam. You're stressed out. Maybe you've got another problem you got to work out. Maybe I'm up there going, you got 5 minutes to finish, whatever. And like, no one wants to have to do this for an exam, but hopefully you would take one look at that and go, nope, I'm not doing it this way. I'm going to try to find the easier way. Okay. But the other big problem with this is that only accounts for the area that I have in blue. Okay. And it doesn't account for the area on the bottom. Okay. So what I want to think back to here is the fact that this is an integral and this is an integral. Okay. So what that means is these are sums. Okay. So what I'm saying is the weighted average of this and the total of that. Okay. So basically this whole thing is a weighted average. Okay. So these are just totals. So what I'm going to do, if I want to work this whole thing, is I'm just going to add this green area down here. Okay. So I'm going to show you, here's the green area, plus, plus. Now, I'm going to show you what's going to make you very happy, because next class we'll work on integrals. We'll do shapes that make sense. This is a rectangle. By the way, I'm not going to get to y bar, but I think you can see y bar is going to be hard. Okay. So really, you want to set this up the easy way. So I could do this. I could do an integral of x bar or x tilde dA for the rectangle. And I could do integral of dA for the rectangle. However, for the rectangle, what is the integral of dA for the rectangle? If I add up all the little dAs, what do I end up getting?
I don't know.
Okay. By definition, integral of dA is what?
A.
A. Okay, what's the area of this rectangle? Length times width, right? Okay, so the length of this rectangle looks like it's going from A to 2A, so it's A. The height of this rectangle it's going from 0 to Ka squared, so it's Ka squared. So area of this rectangle is Ka cubed. Okay, no need to integrate. Okay. Now for this top bit, no need to integrate there either. Okay. What's the x tilde for this whole rectangle? Well, it's right here in the middle of this rectangle. Okay. and it's got a position of 1.5a comma, I guess it'll be ka squared over 2, ka squared on 2. Okay, so that's my x tilde. As I said, when you have a defined shape, it's a lot easier. 1.5a, and I'll multiply that times the total area, which is going to be ka cubed. Okay, and that's all you got to do. Okay, and this is a perfect lead in to the easier shapes, which we'll do next class, but that's how you do that one. Okay, note that this is not within that interval. Okay.
This is considered like a harder problem, huh? Because I found this harder than the one we just did.
You mean the harder than the triangle?
I think the other method, because this is like horizontal and vertical for this problem.
Oh yeah, so it's the same method. It's just about which way do you draw your rectangles. Okay, so the two things that I will give you out of this is this. Okay, so let's suppose we got some random shape. Okay, in this case, I'm going to draw the shape that we just did. Okay, when drawing your rectangles. Okay, so here's your shape. For ease, okay, you have two choices for your rectangles. You can draw them this way, or you can draw them this way. Okay, two things. So this is the y-axis. This is the x-axis. Two things that are going to make this things that I can think of off the top of my head. Two things for ease. Okay, one, you want your rectangle to attach to an axis. Okay, what do I mean by that? See how this rectangle is on the axis? That makes the vertical boxes better. Okay. Okay, this one does not attach to either the x or the y axis, so we don't want that one. Okay, on either side. Okay, so that's one thing that will make your life easier. The other thing that will make your life easier is that you need to, I don't really know another way to put this, but check your limits of integration. Okay, and so like this vertical box, they go from here to here, and notice that it's always defined the same way. Okay, it's always going from the x-axis down here at the bottom to y equals kx squared up here, always. Okay, so that's good. The horizontal ones, okay, it's going from x equals 2a to this line from here to here. And then it's going to be redefined down here. Okay, so that's the two reasons why. I mean, this is the one that's most important. Okay, because that's just it's gonna create all kinds of problems. You know, this one, rectangle to attach to the axis, that's just the difference between having to subtract something off. Okay, that's like not a huge deal. But the limits of integration will determine whether or not you have to split this up into a bunch of different areas. And no one really wants to have to do that. Okay.
Yeah, thank you.
Okay, you're welcome. So anyway, that's all I got for today. Okay, remember the exam has been moved to Thursday of next week.
Thanks for that. That's really helpful.
Okay, cool. And the Centroids will not be on there, and it will be in that auditorium. So,
Great.
all right. I'm going to stop recording. Oh, if I can figure. Oh, that's right. I'm on the wrong.
That was actually pretty fun.
What this math is, it's hard. There's no way around it.
It's fun though. I think whenever you introduce calculus into like a class, people like immediately just like go blank in their minds. I don't know why, but
It's because we don't make you guys use it enough. If you guys use it more, you'd be more comfortable.
yeah.
And you know, I mean, I remember. I remember. So as I say, I'm always critical of the fact that we do not, require this more often. So, or we don't use it more often.
Oh, are you gonna extend the trusses homework on the McGraw-Hill or no?
What do you mean extended?
I mean it's really long. It's like really long, but
Yep, yep,
you don't want
you had 2 weeks.
to.
And I don't want
we
to
had,
extend it. I don't want to extend it because the exam is next week and I want you guys to get it in. So-
okay.
So,
we
yeah,
had-
so I apologize for that. But no, I was not planning on extending it. Plus, let's remember, homework is worth basically nothing in this class.
Yeah. Do you drop homeworks or do you?
I drop a ton of homeworks.
Okay, thank God, because
Because
I hate the one attempts.
I don't actually care about your homework grade all that much. I care that you do the homework and then you learn from it. So if I can quote unquote trick people into doing homework by giving them points for it, great. I don't want to put a ton of points on it because then everybody just cheats on their homework. And then I get a whole bunch of people with like 95 homework averages and 50 test averages. And like, that's no good. So the only reason for the points at all is just because there's some people who won't do anything if there's no points. So, I mean, if I had my way, there'd be no homework points at all. Just,
Thank you. That's really cool.
yeah.
Right.
So yeah, I will drop a lot of homework. I'll drop 2 and as many as 4 or 5. There's also been semesters where I just, is this off the record? Let me stop recording. I guess if anybody's still paying attention. There have also been semesters where I just gave everybody 100 at the end, but I didn't tell anybody. So no one ever knew.
Oh, that would be really cool if you did that.
Yeah, well, I'm sure, but
Weird how like McGraw-Hill, like very weird.